Hello, welcome to this episode of MathMeowTics. So on this episode of MathMeowTics, we are going to talk about multiplying special cases of binomials. There's special rules that we can use to simplify the square of a binomial or the product of a sum and a difference. So the first example that we're going to talk about, or the first special case of squaring of a binomial, is if I have a situation where I have a plus b, and the a plus b, the value, that binomial is squared. All right, well, we know that if we have, let's say, x squared, that is saying x times x. So if I have a plus b and that's squared, then I know that that's the same thing as a plus b times a plus b. Well, the rules for dealing with distribution when I have a binomial, I'm going to distribute this. So I'm going to say a times a, which will give me a squared. Then I'm going to do a times b, which will give me plus, because it's positive, ab. Now I'm going to do ba. Well, I have ab here. b times a is the same thing as saying ab. They're equivalent to each other. The properties of multiplication means that the order of that does not matter. So I can write this as a times b. Again, now I'm going to do b times b, which will give me b squared. Well, these are two like terms here in the middle, so I can rewrite this as a squared plus 2ab plus b squared, which is exactly what our rule that we're given here gives us. Now, I can think of this a number of ways. I can think of my a value as the value that's in front of my coefficient term. So I could think of, let's say, for example, I have 2x plus 1, and let's say that's squared. So I can think as my a value as the value that's in front of x, so then that would be, let's say, 2. So then when I would write this out in terms of this, I need to make sure that I keep an x squared here and an x there. But there's another way that I can think of this so that I don't make any mistakes. I can think of whatever is in place here in that first term, that's my a value. And whatever in place of my second term for my my binomial, that would be my b value. So, for example, let's look at the example here that we're given. X plus 4. Okay? Then if I have x plus 4, my a value is going to be equal to x. My b value is this value that's in the place of that term, so that's going to be 4. Well, so I'm going to, in place for my a, I'm going to write this down here just so that I have room. So now, in place of a, I have a squared plus 2 times a times b plus b squared. Now, I'm just going to substitute values in. So in place for a squared, I have x squared. Plus, I have 2 times the value of a, which is x, times the value of b, which is 4, plus my value of b squared. So that's going to be 4 squared. Now I'm going to simplify this. So then that's going to give me x squared plus 2 times 4 is 8. I can't combine the x with that. Plus 4 squared is 16, which is exactly what I have here. All right, I can also think of that as terms of a coefficient, but I think in the long run it's going to be easier for us to think of whatever is in that first term slot is going to be our a. And in reality, it's not going to matter too much if, let's say I want to do x plus 1, okay, and that's squared. Well, is x plus 1, is that going to be the same as, let's say, 1 plus x squared? Let's see. I'm not sure. So let's find this out. So then my a value is going to be 1 in this case, or x. My b value is going to be 1. So in terms of my rule, I have a squared plus 2ab plus b squared. So that's going to be x squared plus 2 times 1 times x will give us 2x plus b squared is 1. All right, so now let's check the other way. I'm going to erase some of this other stuff so that I have some room. All right, now I'm going to look at, let's see if I have, okay, so if I have x plus, or 1 plus x, and that's squared. So in this case, my a value is equal to 1, and my b value is equal to x. Okay, so now let's look. We're seeing if the order of this matters. So I'm going to write this down. So this is going to be 1 squared plus 2 times a, which is 1, times x plus b squared, so that's x squared. So that's going to be 1 plus 2x plus x squared. And the rules of talking about writing a trinomial or polynomial, any polynomial, in standard form, we're going to order it in where our exponent is the highest. So that's going to be x squared plus 2x plus 1. Well, that looks like they are equivalent, so the order inside the parentheses does not matter, and I can in reality treat either one as A or B. But it may make a difference in terms of negative. Let's see. So I'm going to erase some of this extra stuff so I have some room. All right. Now, here they're same. We have the same formula, but the difference between the sum of this squared and the difference squared, difference being a minus b squared, here it's all positive, but here the first in between that term is going to be minus. So it's going to be a squared minus 2ab plus b squared. I can factor it out just like we did up here with the other one, and it'll give us the same, it'll prove the same rule works. Now in reality, here I have x minus 3 squared, all right? My a value is going to be x. My b value is going to be, we can do this in a number of ways, but I'm just going to say 3. Because the reason I'm not going to say negative 3 is because we know that that needs to be negative when we write that. So that when I write this out in my rules, because it needs to be a squared minus 2ab plus b squared. If I think of it in terms of a negative 3, I might get confused and substitute a negative 3 in here and do a negative times a negative, which will give me a positive, which will not be the same, will not be the correct trinomial. All right, so my a value is going to be x squared minus 2 times x times 3 plus my b value, which is going to be 3 squared. So that's going to give me x squared minus 6x plus 9, which is, in case, exactly what I got here. Now, I want to see if, let's see if I change the order. I want to see if that's going to make a difference. I don't think it is, but let's just check just to be sure. So we have 3 minus x, and we're going to square that. So in this case, my a value is equal to 3. My b value is equal to x. All right. So now I'm going to write 3 squared minus 2 times 3 times x times, plus, not times, plus my b value squared. So then that's going to be 9 minus 6x plus x squared. Well, we're going to need to write this as x squared plus minus 6x plus 9. Look at that. It gives us the same answer. So, in point of fact, inside the parentheses, the order of that does not matter as long as we make sure that we use this symbol here correctly, that we don't use a negative here in terms of our b, or so we only want to use that value for b. All right, and hopefully that makes a little bit of sense. In the next video, I will talk about the product of a sum and a difference. See you then.